lesson. It's called Trigonometric Ratios of Any Angle. And I just put continued there. That's all I did. I'm going to give you a moment to copy down what it says here. Copy down what it says here. We got to talk about everything that's going on here. Because if up till now you have thought trig's pretty simple, things are about to get a little more tricky. Sorry if I take over the screen. I'm just going to do a sound check. Because if this sound doesn't work, then this video doesn't work. It just takes 2 seconds for me to test the microphone. It's working. Okay, back to here. Copy these words down. We need to get to the bottom of what the words are telling us. Again, I did not forget to photocopy. Part of the learning here is to copy down what it's saying and hopefully ask a bunch of questions as this goes on. Maybe I'll explain it. Maybe as I'm doing these questions, I'll explain everything you're seeing in the sentences here. Maybe not. So you make sure you ask me because it's important to understand these questions. They're not off the charts difficult, but there's a lot to understand about what's going on here to be able to do this. Well, just in case you're all copied up, I'm going to add a couple of things to help you understand what this question is asking. It starts by putting a very scary statement. If 0 degrees is less than or equal to theta is less than or equal to 360, that might be enough already to set you off, go, what are we talking about here? So let me just add a little translation there in as few words as possible. I don't want to say too much. I want to give you just the words you need to understand what it's asking. It's saying, only look for answers between 0 degrees and 360 degrees. And if you're like, okay, I was only going to do that anyways, I don't know why I would look for answers outside of that, that's fine. This is giving you permission to do that. In the future, we may look for answers outside of there. So they're just telling us it's okay. All I want is the answers between 0 and 360. And during the lesson, I'll mention how you could get other answers. I'll mention it. Okay. Then I want to underline one letter that should scare you. It says find the possible measures. Underline that S, because that should concern you. Measures seems to imply there might be more than one answer here, but I'll get to that. I'll act like when I'm doing the question for you, I'll act like I didn't notice that, and we'll talk about it. To the nearest degree, degrees are really small. The idea of having decimal degrees is a bit ridiculous for most applications. 1 degree is a really small amount, so we don't have to worry about decimal degrees very often. And then there's a note there, the minus sign only determines the quadrants. What are you talking about? Ignore the minus sign when finding the related acute angle. I put it at the start of the note, but we don't need it till later, because the first one doesn't have minus in it anyways. Okay? So we'll just leave that on the shelf until we run into a minus, and I'll talk about it then, okay? This is the reverse of what we were doing on Friday. On Friday, I gave you an angle and said, use the special triangles to find the ratio. And your answer would be something like 1 over root 2, or root 3 over 2, or 1 over 2. You'd get this answer. Now we're doing it in reverse, like always in math. That's always been the game. We taught you add, then we taught you subtract. We taught you multiply, then we taught you divide. We taught squared, then we taught square root. We're always doing the inverse. So I'm doing the inverse here today. cos theta equals 1 over root 2. Here's what needs to happen along the way. As soon as you see 1 over root 2, you're like, wait a minute, I recognize those. And over here, you make a little note to yourself and go, wait a minute, oh, geez, that's my active board. I'll go way up here. I think up here works. Not bad. Yes, not bad. This is what needs to pop into your head when you see the 1 over root 2. You go, wait a minute, I've seen root 2's before in a very specific triangle, one of the special triangles, 1, 1, root 2. To which you ask the question, do I have to memorize these two triangles? And the answer is big time yes. No faster route to disaster on this upcoming test than not knowing your two special triangles. It's key, vital. For most people, I hand out the test, they don't even write their name at the top. They're like, I can fix that later. I can get my name on it later. Even if I hand it in without my name, we'll figure it out. But I cannot survive without my two special triangles. 1, 1, root 2. What are the angles in the 1, 1, root 2? 45. If you do your homework, you might memorize them by accident. You know, you just worked with them enough that they're automatically in there. So when I see this cos theta equals 1 over root 2, can you hear how slow my voice is going? Trying to very carefully explain the steps. I will do these questions faster in a minute, but I want to show you very carefully the steps that have to happen here. So, here's the deal. I'm going to, by the way, if you're really paying attention, watch for me to miss something. It won't be wrong when I'm ready. You can copy it down. Watch for me to miss something. So if you have a question, get it ready. Get it in the holster, ready to bring out by the time I act like I'm finished. If cos theta is 1 over root 2, build your trig playground. I'm telling you, if you're having trouble with this stuff, get your trig playground down. Your trig playground looks like this. And for those of you who have trouble with angles, maybe your trig playground has this. Don't be shy. Don't be embarrassed if you've got to write these on there. That's a good trig playground. And maybe it relates to what it said at the start. Just look for answers between 0 and 360. And a good trig playground will also have this on it. I'll give you a mark just for writing that. I totally will. If you just write that down and go, I don't know how to do the question, but there's the playground. I'd be like, good, that's a good start, because I know something you don't know. This is a great start. This is a wonderful approach to this question. Now, using that, I'm now going to draw where the angle is. Just by knowing that cos theta is positive. Because if cos theta is positive, it's got to be in this quadrant, in the all positive quadrant. Just put your question in your holster now. Okay? If you get that far, I swear you're home free. I swear you're in the clear. Just draw it in the right quadrant. Because the rest of it's a lot like what you did on Friday. I'll turn it into a right angle triangle. I'll label the sides, but this time I know the sides. I don't know the angle, but I know the sides. I know the adjacent is 1 and the hypotenuse is root 2. Then you take a large, deep breath. You go, if only I knew the angle between 1 and root 2 in a special triangle. I wish I could know. Does anyone know what the angle is between 1 and root 2 in a right angle triangle? 45. Do you see? Special triangle. It just got a lot more special. I mean, it was kind of special on Friday, but now you're like, wait. When you say special, you mean special. That angle's 45 right from my special triangle. Ooh, would you have laughed if I fell on my face? Yeah. Yes, good. That means we're good friends. Good friends laugh at each other when they fall. I'm done the question. There it is. Theta equals 45 degrees. In fact, now I can check it with my calculator. Yeah? So your calculator is helpful here. You're not supposed to use your calculator to do the question. But I can go to my calculator, if I've got a good one, and hit cos 45 and see if I got the right answer. Root 2 over 2. Ooh. Yeah, they fixed it. The calculator fixes it on purpose, doesn't it? So you got to go back and go, okay, what would I do here? 1 over root 2, 1 over root 2. Multiply top and bottom by root 2, and I get root 2 over 2. Okay, good, I'm happy. If your calculator gives you a decimal there, it's no problem. It's no problem, actually. You just get it as a decimal. You're like, wait, that didn't seem so bad. It's not that bad. If you know all the pieces you got to do, if you can juggle all the balls in the air, this isn't that bad. One little fly in the ointment here. Can anyone see it? There's nothing wrong. It's all correct. What did I miss? Let me rewind the video for you. And repeat a sentence that should have made you stop. I tried to glare at you. Wait, Ben's trying to raise his hand. There's another one. Let me rewind to the moment, okay? If cosine's positive, it has to be in this quadrant. There's another place where cosine could be positive. I got to do it all again for here. Almost all trig situations have two answers. There are special cases. Okay, but for now, you can go home tonight going, I'm looking for 2, I'm looking for 2, I'm looking for 2. Because there's another spot, and that's the spot that should or could have triggered you when I said it has to be in quadrant 1. Now, build the trig playground properly. I'm talking to me, not you. Teach properly. If you're having trouble with these, build your beautiful trig playground. Take the time to go, okay, this is 90, this is 180, this is 270, this is 360. Maybe you don't think you don't need it, and maybe in some questions you don't need the whole playground. Put the cast rule on there. Maybe even make one of these papers up and make 45 copies of it. Sell it to your friends. Call it cast paper. There. Now I'm ready to do trig. Yes? Once you have that, you are digging trig. Because what I said was false. I said, oh, it has to be in here. No, no. If cosine's positive, and I'm just looking at it and going 1 over root 2, it didn't have a negative sign. I just look and go, oh, could it be here? No. Could it be there? No. Could be here. The rest of it is just like that question there. Drop your perpendicular down. Put the adjacent, it tells you, look, 1 over root 2, it tells you adjacent hypotenuse. And then your job is to decide what the angle is between 1 and root 2. And as long as you've got your triangle memorized, that's a 45. But now I need someone clever. The answer is not 45 again. It's that much. How much is that much? 315. Now some people have trouble with this, and I'm going to help them out. If you're like, this is the part I didn't like, just trying to figure out what to do here. I'm going to write in this quadrant what to do, and then I'm going to give you something, a helpful weapon, if you're having trouble with that particular calculation. I'm going to show you something that you're going to like, which I don't like to give you, but I will. I'll give you some help. Well, now you go back to your calculator and go, did I get it right? Cos 315? Root 2 over 2. Yes, that's good. Yeah?
So what's our answer?
45 or 315. There's two different answers in the first 360. Somebody really clever goes, couldn't you go around again? 45 and then go 360 around? Doesn't 405 work? Cos 405? The answer is yes, but we're not doing that right now. Yeah, we're not going outside that first circle. We're just going to go once around. Okay? Once around the sun if you want. Let me step about 3 courses ahead. Doesn't spring come every year? Doesn't it come another 365 days later? Yes, yes, we could talk about that. We just want to talk about when's spring this year. When's fall this year? There's spring and fall, done. I don't know how good that analogy is for you. It's not an analogy. Truth. Question?
I thought you were supposed to go to the closest x-axis.
I did. I put the 45 right in there. I went closest x-axis. So I went, okay, if 45 is near the x-axis, what's this angle? 360 minus the 45. Here's my helpful tool.
Would it just be like 45 though?
Oh, that's the related acute angle, not the whole angle. The whole angle. Good. No, I understand your question now. The whole angle is measured from the x-axis counterclockwise around. That's how we measure angles. The related acute angle, let's talk about that name now finally. The 45 is related to the answer. It's the acute angle in the triangle, and it's an angle. That's why it's called the related acute angle. It's related to the angle, it's acute, and will help you find the angle. All right, some help. I hope you know who you are. There's two people I was texting that were having trouble deciding whether to add, subtract, whatever in each quadrant. Here's the beautiful picture that will help them. In this quadrant, you don't do anything with the angle. You just leave it as x. In this quadrant, you go 180 minus the related acute angle. In this quadrant, you go 180 plus the related acute angle. And in this quadrant, you go 360 minus the related acute angle. Why didn't you tell us that on Friday? I don't like memorization tools. It's much better if you just know why it's happening. And some of you are seeing that. You're like, okay, I don't need this. I know what to do. But if you're having trouble with it, extremely helpful to decide what to do with these angles once you have them. Yeah? Lesson over. Really. I'm just going to do different scenarios, those same steps. So I will progressively get faster in each example, as I believe most of you are with me. If you're not, you should stop and ask me. This is not an easy procedure. There's a lot of steps that have to be understood. Do you need more time there? Back to this picture, this beautiful picture. Really good trig stuff. Should really think about making some trig cue cards here.
I might have to in Chicago.
Nothing difficult. I believe it. Nothing difficult. Just too many little things here.
Exactly.
That's what the problem's going to be. You got to be the cat in the hat, balancing all the stuff that's got to go on here. Your best weapon? Practice. Practice is the best weapon. It's the only way to keep track of all this stuff. Back to here. Yes? Are we okay now? Good? Can we do another one? Yeah. You're going to see. I'm just going to do 8 in a row now. Let's just try a new scenario. Sine theta equals negative root 3 over 2. Earlier in your note, it mentioned the negative. It said, don't worry about the negative. Don't worry too much about the negative. We're going to take care of the negative. You're like, I'm really worried about the negative. Wait till you see. The negative's not going to be a problem. Here's what you really need. You need this friend here. You need the triangle. And again, if you don't get these memorized, come test time, I don't know what I'm going to say. I'll be like, you got to have you got to know these, all right? Opposite root 3, hypotenuse 2. Who's got this memorized? What's the other side then? 1. What's this angle then? 60. And you're like, I don't have it. Remember, how are they getting these numbers? I know, they did their homework. It happens by accident for most people. They just automatically memorize them. Here's your memory tool. When it's in degrees, the 3's are beside each other. There's nothing mathy about that. That's just one way to remember it. It's not how I remember it, by the way. I remember 60 has to open up into the bigger side. That's how I remember it. But hey, do whatever you want. You don't need my memory tool. But somehow, some way, when this test gets handed out, you're like, boop, 2 triangles, done. Build your trig playground. Build your trig playground. If you have trouble with angles, your trig playground has these on there. I don't mean that to be condescending, by the way. I don't mean like, oh, if you're having trouble with your angles, maybe. No, I mean, hey, awesome weapon is to draw those angles on there. And then also your cast rule. Big moment. Big moment. If it's negative root 3 over 2, can it be in this quadrant? No. Everything's positive in that quadrant. Sine is not negative in that quadrant. Can it be in the sine positive quadrant? No. It's got to be in the sine negative quadrant. Ah, it must be in this quadrant. Take your question, drop it in your holster, get ready to go.
Yeah, Mr. Todd.
Now, put the sides in the triangle. The opposite of what we did on Friday. On Friday we had the angle, we put the sides on. Now we got the sides. Opposite over hypotenuse, or y over r. Either way, you can think of it either way. So the opposite is root 3, and the hypotenuse is 2. What's the angle with the x-axis in there, related acute angle, that's opposite the root 3? Opposite the root 3 is 60. And then, oh, he gave away the answer. He's like, and then it's 240. Let me just write two sentences if you're like, I can't keep track of what's going on here. I'm going to write one sentence. Therefore, the related acute angle is 60. That is, 60 is related to the answer. It has something to do with the answer. It's not the answer, though. The answer, in festive green, is the whole angle here. Which Nathan already knows. Did you use my little diagram, or did you just know, Nathan? Did you know what to do, or did you look at my diagram I just built?
A bit of both.
A bit of both. I like it. He says, okay, if I'm going all the way around, I got to go do you see the 180 on my trig tool, on my trig playground here? I got to go 180, and I got to go 60 more. Therefore, theta is 180 plus 60 more, which is 240 degrees. So some extra information this time, reaching out for people who are like, I'm not seeing where you're getting this stuff. There's where I'm getting this stuff. Who's right with me? What did I neglect? Nothing's wrong. That's all right. In fact, I can check. Let's check. Sine of 240. Let's see how I did. Calculator. Sine 240 equals negative root 3 over 2. Especially if you got a good calculator, it tells you, yep, you're right. It's all good. What did I neglect? Neil's pointing. There's another quadrant. In the first 360, there's usually 2 spots. It could also be down here. Shh. In the cosine positive quadrant, which is another sine negative quadrant, but I'm putting the whole playground in there, trying to get everybody involved. Opposite is root 3, hypotenuse is 2, so that's 60. Therefore, this time, theta is 300. Because I got to take the 360 this time and subtract the related acute angle. See, that related acute angle, it's related to the answer. The 60 helps you get the answer, but it's only related to the answer. It's not the actual answer. Unless we're in quadrant 1. In quadrant 1 it would be, but okay, we'll just leave that alone. Oh, we could check too. Sine 300, sine 300, negative root 3 over 2 is good. Yeah, so your calculator's there to aid you. But if you just wrote down, if I gave you this question and you wrote down theta equals 240, theta equals 100, how many marks will I give you? 0. This time, the answer is worth nothing. I'd much rather you get it wrong. Screw up your angles here, put a 30 there, get 210 and 330. I'll be like, oh, you just missed it. All right, it's okay. 3.5 out of 4. Huh? Show me the work on your trig playground. Tell me your questions. I'm not acting like it's easy. It's shocking. After leaving grade 10 and going, oh, I love trig. Trig's my favorite. Trig's like, do your seatbelt up. We're just getting one. This is only chapter 1 of trig. We got a whole nother chapter to go. Gets a little triggy. Did I ever use that joke, Van Mead? Yeah, basically, all right. More time here? Let's do another one. Yeah, let's just keep at it. I'll just keep, by pure repetition. Secant theta equals 2. What? Is there a 2 in a special triangle? Oh, there is a 2 in a special triangle. If this is going to work, I need the special triangle that has 2 in it. Which one has 2 in it? 1, 2, root 3. I see a couple people mouthing the words. You're like, I don't know which one it is. It's time to build little flashcards somehow to get yourself memorized here. 1, 2, root 3. 30's by the 3. 3's are beside each other, if that's the way you want to memorize it. And then 60's over here. Does that help? Maybe not. Some people are like, no, I don't like secant. I'll turn it into a cosine question. Thank you very much. I like that too. Okay. Build your trig playground. Here we go. I'm going to try and color code it properly this time. One more time, I'll act like I don't know what's coming here, okay? And then for the next one, we will do better.
Oh, Mr. Todd. Yes. Why you gotta hate, bro? Why you gotta hate?
Which quadrant could it be in? Could be in the all quadrant. Quadrant 1, sometimes people call it, because it says cosine is positive. So it could be in the all positive quadrant. So I draw my right angle triangle. And I go, okay, label the sides. Adjacent over hypotenuse. Some people are good enough at secant that they go, no. Hypotenuse over adjacent, and they do it that way. Great stuff, but you don't have to. You can just switch to cos and go flip it over. What's the angle between 1 and 2? 60. And in this quadrant, you don't have to do anything. 60 is the related acute angle, but it's also the whole angle. So here theta equals 60 degrees. That's one of the answers. But there's another possibility. Build a whole new trig playground. Mr. Todd, I don't think I need the whole playground anymore. I think I can do this without the playground. Okay. You might not need all the labels, but you have to show me the picture. So where did we go here? What other quadrant are we in? Oh, I didn't put the whole... I said it and I didn't do it. C, A, S, T. What other quadrant? The cosine positive quadrant. And if this is starting to click, where you're like, oh, just two quadrants, draw them both pictures. Yeah, I didn't say they were hard. I just said there was a lot of steps to know. There's a lot of things to know to be able to handle this. Draw the triangle. Adjacent hypotenuse. Theta equals 360 minus the 60. 300 degrees is the other answer. How many is you going to do, Mr. Todd? I think I sort of got the gist of it. A couple little curveballs coming. That's all I got left is to show you a couple curveballs that might happen here. Okay?
That way he grabs my binder, right? Mr. Todd.
Van Mead, I'm really sorry.
See you later. You're the whole time. Ow!
I'm going to call your moms.
You had to get my whole arm. Look, my arm's red. Oh, my arm's
Any questions here?
Yeah, stay over there.
Listen, we're trying to live in an inclusive society. We're trying to bring everybody in. Everybody's welcome. Why should some triangles be special and other triangles not be special? That ends now. As of now, I'll show you how to make every triangle special. You can still do it this way. You can still go over here and go, I need a special triangle. This time you won't know what the special triangle is, though. So you go over here and go, oh, I don't know what's going on here. But I can find theta. All I need is just a little tiny bit of help to make every triangle in the universe special. I'll just do cos inverse. Cos inverse of the 0.4384, I can get the angle in the triangle. Try it on your calculator right now. Make sure you're in degree mode. I'll do it on my screen here. Cos inverse of 0.4384, 0.4384. Answer 63.998. Like I promised, 60, like nearest degree, is plenty in virtually every regular application. Now I've got my angle. The rest of it's the same. Because that should have been the question. You guys were very patient with me as I was doing these questions. Like, so every question in the universe is 30, 60, or 45? That's all you've been using is 30, 60s, and 45. No, those are just ones where you can get nice exact answers. See, this answer was not exact. 63.998160067. You know, it's not perfect. I rounded it. But I can still do it. 64, and then the rest is the same, I swear. I don't have another curveball here. I draw my trig playground. I put on my angles, if needed. And I'll show you what I mean by if needed. I put on my cast rule. There, that's what it takes to be ready to do a trig question, is draw that little picture. Then I go, okay, I've got my cosine is positive. So it must be in this quadrant. It's the only quadrant it could be in if cosine's positive. No. But anyways, in the first part of the question. But now I know my related acute angle. Cos inverse gave it to me. It's 64 degrees. So my theta is 64 degrees. I'm looking for someone with a skeptical look on their face. I don't know. Let's try it. Let's check the calculator. Let's do cos of 64. It's perfect. Cosine 64. Now, if it was a really good calculator, and when I pressed equals, instead of giving me the answer, it would go, you just did the cos inverse on this. You know what's going to happen. Why are you doing this? You cos inversed it to get 64. Of course, when you cos it, you're going to get 0.4384 rounded off. Yes? But that is not all. Oh no, that is not all. What am I missing? There's another quadrant where cosine is positive. Down here. C-A-S-T. There's my 64. Challenge yourself. If at the start of class you didn't know how to get these angles, challenge yourself to go, okay, so what do I do to get the answer? I don't have to do anything in quadrant 1. Quadrant 1, very friendly. That's why we made the angles go counterclockwise. So quadrant 1 would stay very friendly. In this quadrant, how do I get the full angle? Ben. 360 minus the 64, 296. You're like, is it right? Is it right? Now your calculator can help. Say, okay, well, check it out. Cos 296 equals 0.4387. You know, round it off. Because I went nearest to degree, I'm off by 10 thousandths. You know, 1 or 300 thousandths actually. I'm not, you know, that's why nearest degree is good. It's pretty close. Okay. Let me just put this all together, Mr. Todd. If it's stuff in a special triangle, use the special triangles. If it's not in the special triangle, just inverse it to get the related acute angle. Then draw my two pictures. Yes. But do you have questions? How many more do I got to do? I'm getting a little tired here. EF. EF. Oh, EF. That's all. The next one just brings everything together. Everything that could go wrong, it's going to go wrong in the next one. Ben, question.
Can you just draw it on the same?
Once you're really proficient, yes, you don't need two different grids. It's a visual thing I'm doing. So as many people as possible don't forget the two answers. And it can mess you up. These diagrams can get a little messy. So it can mess you up if you're not careful. But if you're like, no, I got it, then yes. Okay. If you've fallen asleep, come back for this one. This one does everything wrong. Everything that could possibly go wrong goes wrong here. If you understand this one, you're home free. It says tan theta equals negative 0.1944. 0.1944 is not in one of my special triangles. Special. We're going to make it special, though. We're going to make our own special triangle. Everybody gets to be special. And then I'm going to do something you're not going to like. Stick with me. I'm going to find this theta. I'm going to go theta equals tan inverse of 0.1944. It's the right thing to do, but if it annoys you, good, you're going to have a question. You got the you got the question in the holster? Yeah. No.
It's because it chooses
Hold.
the quadrant.
You guys have all the questions. Stick right there for a second. Everyone over here, just pretend Mr. Todd's getting old and he's made a mistake. Then you're going to ask the question, and you're going to give the answer. Are we all ready? We're all set up? All our dominoes are in line? Okay. Right now you're like, I'll just wait to see if someone asks him, but he's definitely forgot something. He is definitely losing it with his silly Mickey Mouse shirt on. Tan inverse 0.1944 equals 11 degrees. The related acute angle is 11 degrees. I'll just keep going. You can still believe I've messed up. I'll just keep going. Get your question ready, all right? Because I hope I'm going to answer it, actually. I really hope. Build my trig playground. C-A-S-T 90, 180, 270, 360. Everyone who's upset that I missed something, get ready. I'm going to try to say something super clever that makes you go, oh.
Liam, what's your question?
Get ready. No, get ready. No, wait. I'm going to try and answer it. Tan's negative. So which quadrant? Could I go on the A quadrant? No, everything's positive there. I can't go in the A quadrant. Could I go in the S quadrant?
Yeah.
Yes. So by putting it in the S quadrant, I've taken care of the negative. My related acute angle, I found out, was 11 degrees. Go, question.
And isn't it negative?
Isn't it negative? I ignored the negative till, oh, no, you know, go.
So Liam, if you paid attention, you ignored the negative so you could find which quadrant it goes in.
That's right.
What's your mark?
Let me,
Talk about my paying attention. What's your mark?
here, look.
Big black.
This will help. This tells you what quadrant.
I love you.
That's what the negative's telling you. The 0.1944 says what triangle? That is extremely helpful when you're thinking these through. So I ignored the negative and went, okay, I just need the triangle first. Hold on. I just need the acute angle. I'm not going to use negatives at all. Negatives is for when I'm drawing on here.
169.
111. Then I go over here and I go, okay, now theta is 180 subtract 11 degrees. What was it? 169 degrees. Settle down. It's okay. It's going to be okay. It's just another number, all right? Yeah.
My bad.
But that is not all. Oh no, that is not all. I could also be, what's the other quadrant it could be in if tan's going to be negative? Here? Here. Related acute angle, 11 degrees. Take the 360, subtract the 11 degrees, 349. I don't know, Mr. Todd. I think you messed up on the negatives. I'm sure you did. I'll type it in, but I think it's going to be wrong. Tan, 349. Before I press equals, this calculator does two things. The calculator is going to think about it and go, what's the ratio? Then it's going to go, okay, well, what sign should I use? So it does two different things. So when I hit equals, I do get negative 0.1944, rounded, because it does two different things. It goes, what quadrant? What triangle? That's what those two pieces of information are telling you. So you can ignore the negative in step one just to get the angle, and then you'll deal with the negatives with the quadrants. This deals with the negatives all on its own. You don't have to do that here. That's what the start of the note was telling you, by the way. Now you're ready to go back and highlight the start of the note. Start of the note says, the minus sign only determines the quadrant. Ignore the minus sign when finding the related acute angle. Yeah? And that's why I got you to copy it down. Because I went, ugh. Maybe they need to write it down to hammer it into their memory so they know they can ignore it. Last example. Cosecant.
Sorry for this interruption. This is for any students who have not picked up their school photos or academic awards. Please come to the principal's office now. Again, this is for any students who have not picked up their school photos or academic awards. Please come to the principal's office now.
I encourage you, if cosecant annoys you, to not play around with it. Just turn it into sine. So this is sine theta is 1 over 1.7013. Can we agree that 1.7013 is not on one of the two special triangles?
Yeah.
So I go over here and I make a new special triangle. Here's my, why should this triangle not feel special? And to find that theta, I go theta is the sine inverse of 1 over 1.7013. Now, in your own words, not in my words, why am I allowed to ignore the negative here? I'm going to fix that. I'm going to take care of that with my quadrant choices. My calculator can handle this no problem. Sine inverse of 1.7013. Because you notice your calculator doesn't have a cosecant button. You've got to switch to sine to be able to get your calculator to handle this. So I'm doing sine inverse bracket 1 divided by 1.7013. Do you get 36 degrees? To the nearest degree. The rest I'll do fairly quickly. To prove it can be done fairly quickly, maybe you'll do two of them at once, will you? You'll get both at once because you know what's coming. You're like, okay, it's got to be in two different quadrants. Sine's negative, it could be down here or it could be down there. Put my 36s in next to the x-axis, and I get theta equals 180 plus 36, which is 216 degrees, or theta equals 360 minus 36, which is 324 degrees. And I only did that fast not to rush, just to show that when you get to the homework, it's like, there's like 12 of these. The first couple might take you a little while, but it should go It should start going quickly once you get good at them. It's like boom, boom, here, here, boom, 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 boom. You know, it should start moving along pretty well. Once you know what's going on. That's now questions 6 to 10 in Friday's homework. Again, my apologies if you jumped in and tried to take a shot at 6 to 10 and you're like, I don't know how to do any of this stuff. That's my fault. I should have said, just do 1 to 5, and we'll pick up the rest of it here. It needs 2 lessons. This says page 7. There's not another page to this, is there? No, you don't care. But do you have questions? Some people do dig trig, actually. Don't get scared by other people's opinion of this. Some people are like, hey, it's better than factoring zeros complete the square. Yeah, woo, I like it this way better. Just draw a nice little picture. Put your angles on there. Get your answers.
Images of complete the square strength of from the